Hello, my name is James Lewis, and today I'll be presenting the role object design pattern. This pattern focuses on allowing an object to dynamically take on different behaviors or responsibilities, what we would call roles, without needing a huge inheritance tree. My demo and explanation will show how this is done in C++, using the UML structure you will see later. So to start, what are design patterns? Design patterns are reusable blueprints that help us solve common software problems. They make systems easier to maintain, extend, and understand. The role object pattern in particular focuses on composition over inheritance, meaning instead of creating subclasses for every variation of behavior, we can attach or detach behaviors dynamically at the runtime. The problem statement. Let's start with the problem this pattern solves. So imagine we have a single object like a user. The user then can be a customer, supplier, or employee. Using inheritance, you'd end up with multiple subclasses or even multiple inheritances, which could get messy and confusing. This leads to rigid hierarchies, duplicated code, and makes it hard to change an object's role at runtime. The role object pattern eliminates that by separating the core object from its roles. The intent of the pattern. The main intent of this pattern is to let an object dynamically change its behavior by adding or removing roles. It helps us avoid subclass explosion, where you have dozens of variations of one class, and instead it lets us have a single object play multiple roles at once. So for example, one user could act as both a seller and a buyer in a e-commerce system. So the solution concept, how does it work? The idea is to use a core object like user and give it role objects like seller role or buyer role. These roles define specific behavior and can be attached or removed at runtime. The base class doesn't need to know what role exists. It simply manages them. That's basically the essence of composition. We combine parts dynamically rather than hard-coding relationships through inheritance. And then here is the UML structure I mentioned earlier. The main object or component core maintains references to multiple role components. So each role inherits from a common interface, allowing consistent behavior calls. The core and roles can talk to each other, which keeps the system flexible. In my demo, the user is the core, and the seller role and the buyer role are the roles, obviously, and it directly follows this structure shown. Alright, so the pattern participants. So these are the pattern participants that make up the pattern. The component is the shared interface. It defines methods like behavior or add role. The component core or user is the main object that holds multiple roles. The component role is the abstract base class for all the roles. And the concrete roles are the roles like the seller role and the buyer role. That has extended behaviors. Finally, the clients interact with either the role or the core depending on the operation. Key relationships. So there are 3 key relationships in the UML. The composition, the user owns multiple roles. That's shown as the diamond relationship in the UML. Delegation, roles can call functions from the user through a reference back to the core. And finally, polymorphism. Since all roles implement the same interface, they can be treated the same way by the user or the client code. This combination allows a lot of runtime flexibility. So here's the C++ implementation of interfaces. The component interface defines the common methods like behavior, add role, and remove role. Both the user and the role classes implement this interface. This makes it possible to treat them like interchangeably and ensure that the roles all share a consistent structure. This is the implementation of the core object. So the core object in this case is the user along with the base role class user role. Each concrete role like seller role and buyer role extends from user role and overrides the behavior function. So you can notice how each role keeps a pointer back to the user. That's how they can access the core's data or methods like if needed. It's basically a two-way connection. So this is the demo usage. It's like the main function that the pattern or demonstrates the pattern in action. We create a user. Let's call her Alice. Then attach two roles, a seller role and a buyer role. When we call user behavior, the program runs through each role and executes its specific behavior. The output shows that Alice can both list products and buy products, proving that one object can take on multiple roles at the same time. And then obviously there's some clear advantages and some clear disadvantages. First we'll go through the advantages. Some clear advantages are the composition replaces inheritance, keeping things pretty flexible. Roles can be added or removed on the fly. It promotes modularity and reuse. On the downside, it does introduce more complexity. You're managing like multiple role objects, and it can also be harder to trace where certain behavior comes from during like debugging, especially when you have roles that overlap. Some real-world examples that you may see is like a e-commerce. So users can be buyers, sellers, and admins simultaneously. In video games, you can have a character that can be a warrior or like a healer. In IoT systems, a single device act as both a sensor and a controller. And in enterprise-like software, so employees switching between multiple departments, basically. And yeah, the conclusion to wrap things up, the role object pattern lets us build flexible and maintainable systems where behavior can be dynamically assigned. It's perfect for applications where entities can play multiple roles simultaneously. By relying on composition instead of inheritance, we get runtime flexibility without the rigidity of deep class hierarchies. In short, we don't change who the object is, we change what it can do.